Hello everyone, we come to the first module in statistics. This is going to be the groundwork when we go ahead and do regression and multi-ripple regression analysis. Start the overview of the module. We'll understand what a normal distribution is. We'll actually spend more time. I'll be talking more about standard normal than normal distribution. Z-score is very important. How you build a standard normal. We'll have I'm going to be talking about Bernoulli distribution, just going to be an overview. There'll be no examples in it, and as we go forward, we're going to build on this. A couple of modules are totally dedicated to understanding Z-score, Bernoulli distribution, and going forward, I'll also be talking about other forms, geometric distribution. And let's start with this module. Whenever I'm talking about normal distribution, what you're talking about series of distribution which we plot, it comes as a bell curve. It's got a mean and a standard deviation. So two most important characteristics you need for a normal distribution is a mean and a standard deviation, and then you can build a distribution. It's symmetrical and unimodal. That is, it's got one highest value. And as we'll see what's the difference between a normal distribution and a standard normal. A normal distribution can have any kind of standard deviation and a mean. When you plot it, it's going to be like a bell curve. Come to a special type of normal distribution, that is standard normal. This is something which I took up in the CAPM series, captured pricing model series. It's got a kurtosis of 3, so that's known as heaviness of tails. Excel will be today talking about kurtosis. It's got a mean of 0 and a standard deviation of 1. So we can take any distribution and convert it into a standard normal. It need not be a normal distribution. Normal has got its unique property, that is the 68% of the observations come in the first standard deviation on either side. So it's got a mean of 0. On the right hand side is the positive side, on the left hand side is the negative. When we're calculating the Z-score, this is going to be very important. 95% of the distribution comes to second. That's why mu is the mean, mu plus standard deviation, and above this third standard deviation on either side is known as outliers. Outliers are very important. You could have as high as 5 times the standard deviation, 7 times the standard deviation. But unlikely it is those events to happen. But that's why the CAPM model was so important. We understood that you should be prepared, you should accept that there will be outlier events. We talk about Z-score, we talk about might of standardization, which I've talked about. How do we score? Is the mean and standard deviation is given by sigma. Take any value and convert it to the standard normal through this formula, which is known as Z-score. So Z-score is just that shows the number of times the standard deviation is above or below the mean. When you're looking at standard deviation, 2 is at the center. You will get either a negative Z-score or a positive Z-score. So that Z-score is going to decide how many times it is above a standard deviation or below standard deviation, taking a normal distribution. This has got a mean of 0. So when I'm talking about Z equivalent, there's the first standard deviation, it will come out here. When you're talking about Z, is just giving you basically how many times, what times it is above or below the mean. It's going to come somewhere out here. So this is where you will be getting Z equal to -1. When you're talking Z equal to -1, you'll always be getting a figure. So Z gives you the probability distribution chart. You'll get a percentile for every Z value, and we look at it what we mean. Let's get a Z value and I calculate from the distribution. I get first I would get a distribution. I'll calculate what is the mean. I'll calculate what is the standard deviation, and we'll see how it's done. I get all these two figures, 1 and 2. Then I can calculate Z-score. Z-score is come as 0.85. What it means is it's 0.85 above the mean, and mean is always 0. Once we get a Z-score, we'll find the probability or what percentage it is at that particular point. Talk about mean. I'm just looking at it now. I've got a Z of 0.85. The distribution which I'll get is to the left of the curve. To 0.85, we'll refer a chart, the probability distribution chart, which will assign us a probability, a percentage. That percentage means that it will give you area to the left hand side of the curve. If you get a Z-score at 0.85, it's going to be minus 0.85 here somewhere. And the value which you'll get from the probability distribution chart will be on the left hand side. Of a standard normal is always 1. So if you want to find area here, which is on the right hand side, you will take the area which at that particular Z point and subtract it from 1. So you will get the area on the right hand side. We look at a series, and from that series we understand how do we calculate the mean and how do we calculate the standard deviation. The standard deviation you can directly calculate in an Excel sheet. This is very important. Z-scores work with any kind of distribution. The area under the curve is always equal to 1, which I talked about. Z-scores always give you a corresponding percentage. So whenever I'm talking about normal, let's take this as 0. So out here you can go, this is the positive side. It will always be positive. If you go here, it will be negative. If I'm given a normal distribution or any distribution, I can easily know whether the z will come negative or positive. If the value is above the mean of the distribution set which I have, then I'll always have a z which is a positive value. Otherwise, z will be on the negative side. Of how to calculate normal. Standard normal always has a mean of 0 and a standard deviation of 1. However, for a normal distribution, how would you? So if whenever I'm writing NT5, 3 mean is 55 and standard deviation is 3. If I'm writing, if I need to represent mean 9 and standard deviation 2, I'll be writing and standard deviation 2. Protocol, everywhere you will see in the books. If it's in a lot of books, it might not be, you could refer to Open Intro, which is very good, freely available statistics book. I think it's one of the best you need to at this point of time. And this is how the representations of the normalized curves take place. You're going to take the following steps. You will first convert. Now, whenever we are talking about Z distribution, which I talked about, this is how you're going to be doing. You have a normal distribution, any distribution, and you want to convert it into a standard normal distribution. So first you're going to calculate the Z value. Z value, you need to have the mean of the distribution, which is normal distribution, and the standard deviation. Once you have that, then you calculate the Z value. Then you find the percentage of that particular Z value to the normal probability chart table. You will be given a table where both negative and positive values. Now the area under the curve on the left hand side is always given. So on the right hand side, you can always subtract it from 1. I've already shown you how we do a normal calculation. See how we'll use a data sheet. It's a very normal data sheet which I've created. How we find the mean, how we find the standard deviation. This I can round off. It's always good to round off in 2 digits. So this approximately becomes 0.82. So this is the Z value. The Z value is on the positive side. What I want is I'll get the value. Whenever you're looking at a standard deviation and you get a value and an area to the left hand side of the curves. Assume the weight. What is the probability that the weight which will be given that it is heavier than. So whatever percentile I get for 0.82 means that it is greater than whichever percentage comes than the rest of the sample. Always gives you a greater value. We'll just go now and check, and we'll understand how do we look at Z-score. This is a standard normal distribution. We always get area to the left of the curve, which is the Z curve. The value as 0.82. So whenever Z, I'll first look at the first digit will always give me the value of Z. 0.82 means that I'll look at 0.8, which is out here. And when I look at the column, I will find out column is given from 0.001, which means if it was 0.03 or 0.83, I will look at this column, but it is 2. So 0.8 is the first column and the intersection from the column side. So row is 0.8. I'll always look at the row first. So row, I look at 0.8. Now I'll go to the columns, and the columns I'll go to 0.02 because it will be 0.82. 938. So I'll round it off to 3 digits and we get it as 0.794. And I've got as 0.794, which is nothing but 79.4%. I'll keep it as, so this is the probability, which is so what is the probability the weight of the person is? The probability the weight of the person is like 79, or you can say is as 79. Look at another example. The person is randomly selected. What is the probability that the weight of the person is at least 72 kgs? Mean is 60. It's very positive that the Z value is positive. Calculated, we use the same formula as score. The Z score comes as 1.09. 1.09 is roughly 1.1 deviations up the mean. If mean is 0 here, this is coming as 1.091. So what I need is that the person is at least 72, which means it is 72 kg or above. I want the area out here. We'll go and find the area what is under 1.09, round it off, and the Z value as 1 and the column will be on 0.9. You get that value, we'll subtract it by 1 because what that value will give us is area out here. What is the measure would be coming in? I will get an area out here. This is not what I'm looking for. I want what is the area here, which is 72 and above. So for 72 kg, it's corresponding to the Z value is 1.09. I'll get that percentage value or the probability value, which we call the percentage value, and subtracted with 1 because the area under the whole curve, which is like the standard normal, is 1. If I'm getting the area out here, 1 minus this area will give me area the curve out here. So this is the area which I want. Looking at 1.09, I'll first go and find out where 1 is. Once I've got the figure of 1, look at the column. If I look at the column, I get this as 0.86. So figure, now we have 1.09. It corresponds to 0.86214. I'm given the area which is on this side. This is the area which I'm giving. This is not the area which I want. I want what is at least, so if I'm taking, which I've shown, it is almost 1.1 standard deviation up. I want the area out here. So then 48 kg. We can directly see that if the mean is 60, so the Z value will be negative because it's 48, so which is less than the mean. So 48 minus 60 gives you, so this is not exactly the same figure, but it is coming on the negative side, the mean, and this is the first deviation, so which is precisely minus. This is going to give me the area on the left hand side. What is the probability of the is less than 40? Directly you get 13 point, which is the same figure for negative, for the negative figure. Person is selected and the weight is 52 percentile. What is the weight? Now here we are trying to find the Z value. The percentage. So let's say this is 0. For percentage for some Z value which is positive because it's 52. It was less than 52, then it would have been here. For a 52, because it's equally divided into both sides, for 52%, take this as 0.52. Figure which I'm looking at here is 0.52 or 0.52. You keep going in, is 0.5. So it is either 0.05 or 0.06. You will see, and if you, there are two things you can do. Either you could, the mean of these two values 0.06 or 0.07, if they're equidistant, very close to each other, or you can do whichever is closer to which of these models. So it is closer to 0.05. If you subtract 52 minus 0.51994 and 52, it will come to closer to 0.05. The value of X. Now I know the mean is 60 and the standard deviation 11. 60.5 equal to 60.5 kg. Got a question on the CAPM. First documentary, educative documentary, was on capital asset pricing model, CAPM. Now I've got this question. This question is from Open Intro Stats. This is a very interesting question because this clears a lot of concepts. CAPM is a financial model that assumes returns on a portfolio to be normally distributed. Right? We looked at capital pricing model. We'll not go in depth in that particular right now, but now we are going to look at this question, how to solve it. Portfolio has an average gain of 14.7% and a standard deviation 33%. A return of 0 means the values of portfolio has not changed. Negative value means you are losing the money. What percentage of the portfolio loses money, which is less than 0%? This is what I want. I want to what is the cutoff for the highest 15% of the annual returns of the portfolio. So if taking it and I'm cutting into a bell curve, I want to find what is the cutoff for the highest 15% of the returns of the portfolio. 0%. So let's put it as 0. So anything which is less than 0 loses money. That value of Z score, I'll calculate the Z score value. The same question, the Z score value will be 0. Value 0 and negative. Mean, the mean is 0.174. 14.7 is 0.174 and the distribution is 0.33. If you calculate this as minus 0.445, you can approximate this to 0.45 minus. You need to know the value of minus 4. Because anything, when we put out a curve, now this is 0, this has come somewhere as less than half of the one standard as minus 0.45. Now if I get a probability here, it will give me what is the area under that particular value, which is under 0. What I want to find, what is the portfolio which loses money, which is less than 0. So anything which I come here will give me the area on the left hand side less than 0, which is precisely what I want. So I put it, estimated is minus 0.45. This is 0, 1, 2, 3, 4. 4, 5. So I've got to 4, 5. It is 0.32636. So I'm taking 32.6%. So what percentage of the portfolio loses money which is less than 0 is 32.6%. To making a standard normal, which is what we do in the what the question is, if this 15%, the cutoff, what is that value from, what is that percent of return cutoff for the highest 15%? What I want is the Z value at this particular value. If this value is this 15%, other way to look at this is this is 1 minus 0.15, 0.85. Because at 0.85, I get the area on the left hand side of the curve. So 15, to see the top 15, you could also equate it as 0.85%. So I want to get the value of Z value for which the percentile is 0.85, which is 85%. I'll go and refer. The Z value for 0.85 is 1.04. That, what is that percentage, which is X? Yes, I know standard deviation is 33 and the mean is 0.45, so 1.47. what is the highest 15% of the annual returns? What is the cutoff? So the cutoff is 49%. So the cutoff is 9%. So which means that if you are taking the standard normal is at 49%, above which you'll get returns higher. So this is the cutoff. If I'm taking this, not the Z value, this is that in percentage I'm taking as 49%.